There have been a few changes on our nation's roads since 1959. Designs of car have come and gone in the passing affections of the motoring public. But the truest loves, like the greatest designs, are eternal. Over 5 decades and half a dozen production models and hundreds of inspired modifications, the Mini continues to hold its own against all comers. It's economical, it's reliable, it's nippy and fun to drive. Not all Minis, however, are created equal. There cannot be many lovers of the Mini who've not heard the name Cooper S, even if they've never had the pleasure of owning or driving one. It's a legend in its own time. When first introduced in 1963, it took the motoring world by storm. A tiny, innocent-looking car capable of taking on the best and beating them. Such astonishing performance didn't just happen. It was the creation of great names such as John Cooper, Paddy Hopkirk, the late Daniel Richmond, and Janspeed Engineering, subsequently the largest tuning company in Europe, was involved right from the start, under this man, Jan Odor. Set up over 27 years ago, Janspeed's early reputation was built on a series of Minis that turned the world of saloon car racing upside down. From there, through Datsuns, Fords, Toyotas, and each succeeding generation of the mighty Isigoni's brainchild, shelf loads of trophies have followed. You can't buy a Cooper S today, but through this video, Janspeed will show you how to transform your standard Mini into a car faster than the classic Monte Carlo winners, and yet fit for the open road. We'll be dealing with 2 levels of modification, the more basic and cost-effective Phase 1 with the engine in place, and the total transformation, Phase 2, which is possible with the engine removed. A team of experts spent many hours discussing the most viable modifications for this project, to remove the guesswork of the inexperienced performance engine builder without access to professional engineering facilities and expertise. Over a quarter of a century of engine development for high performance and racing is of course why so many customers come to Janspeed. The power modifications that will be shown in each phase are the result of thousands of dyno tests Janspeed have conducted over the years. Recommendations concerning initial carb and ignition timing data for all the various engines will be made as we go along. The first job is to road test your car for suitability, to determine if any problems exist, listening for undue engine or transmission noise which may indicate a possible problem. There's no point in modifying a car if it is not mechanically sound. Firstly, you'll not get the full benefit of the modifications, and secondly, the extra power can cause a failure of worn components. A good Mini overhaul manual is a great assistance here. Now, for the engine. Using a compression tester, check the pressures of each cylinder and note them down. If the difference is more than 10%, then something may be amiss. To find the problem, check tappet settings and then squirt a teaspoonful of oil into the walls of the cylinder, wait a minute and repeat the test. If readings increase slightly but still differ, then a head or gasket problem is indicated. If there is a marked difference on reading, worn bores can be suspected. Now check the oil pressure. The readings must be within manufacturer's specification. If they're out, the problem could be serious, a worn crank and bearings. To help us show what can be done, we acquired this 73 Mini, which at some time in its checkered past had been owned by an enthusiast. It had many parts on it that we need for high performance already fitted. If you're planning a Phase 2 advanced modification and need to remove the engine, the Haynes manual is essential. We'll be showing the general procedures here. There will of course be many variants possible for each engine. First, isolate the battery, drain the fluids and remove the brake servo if fitted. To avoid loss of fluid or paint damage, the end of each hydraulic line should be plugged. Next, the air cleaner assembly is removed and the exhaust disconnected at the junction with a downpipe. This allows the exhaust system to be dropped from under the car. Remove the shaft couplings from the transmission and disconnect the remote gear change mechanism. Next, remove the starter cable and likewise, though easier said than done, the engine mount securing bolts. In extreme cases, these may need to be chiseled off. The engine, steady, both at the block and body ends, is unbolted and removed next. This is followed by the disconnecting and removal of the hydraulic clutch lines and the slave cylinder itself. With the removal of the heater hose, the engine is about ready to be lifted. For this, you may have to rent a suitable engine lift. Once lifted out and cleaned, the engine should be stripped for checking. For cars that have done more than 40,000 miles or older than 5 years, the radiator should be flushed or renewed. Next, remove the fan and alternator. With all the easily accessible items removed, we now turn to those needing special attention, the clutch housing. First, ensure that the number 1 and 4 cylinders are at top dead center. To remove the flywheel, a special puller will be needed. Parts removed from the rotating assembly should be marked and kept in order to preserve the original factory balance. Unless your clutch plate is perfect, it should be replaced. Once the transmission end cover has been removed, the block can now be separated from the gearbox. For the moment, the gearbox can be put to one side, though inspection of the output couplings is well worth the few moments it takes. Damaged ones like this will need attention or replacement, as will the corresponding rubber couplings. The next major item to come off will be the head. First, remove the rocker gear from the cylinder head. Before we deal with the rest of the engine strip down, we'll see what it takes to strip, check and ready the head for modification. First, we inspect the head face and gasket, especially between the bores. These can give a clear indication of impending gasket failure. If no intercylinder cracks are evident, the head face is cleaned, ready for further inspection. What we're looking for now is any water-related damage, sunken plugs or obvious cracks. If all seems well at this point, then strip the head. This operation starts by unsticking the valve retainers with a sharp tap from a soft metal punch and hammer. Now, using your valve spring compressor, release the spring retainers. In case no new parts are needed, be sure to put all valves in a numbered strip for return to their original locations. If a valve is bent or has seized at some point where it picks up in the guide, it may need driving out. Valve to guide fit is very important. Power can be lost if valve stem clearance is too great. A provisional wear check can be done by moving the valve from side to side across the width of the head. A valve with this much side movement is worn far too much. By and large, the exhaust valves suffer more wear than the intake valves. The particular valve shown here has suffered a seizure in the guide and should be considered scrap. To decarbonize the head for further inspection, an electric drill and a wire brush are handy pieces of equipment. Without necessarily using undue pressure, clean the carbon from combustion chamber surfaces and the entrance to the ports. The next operation is an all-important crack test. Many heads are prone to cracking, and a magnetic crack detection check, as shown here, will find the fault. Usually the crack occurs between the two valve seats. Here is a classic example of an interseat crack. Such a crack renders the head completely useless. If sound, thoroughly clean the casting down to bare metal. These are before and after shots. Now the removal of the block studs. Ideally, this is done with a proper stud remover as seen here, but it can be done by locking two nuts together. After tapping back this lock washer, insert a piece of wood to prevent crank rotation during damper removal. This will now allow the unbolting and removal of the timing cover. This gives access to the timing gears. As indicated by the slack in the chain, this one has worn past usable limits and if used would be the source of unwanted engine noise. Now that the timing gears have been removed, we have easy access to everything right up to the block face. This means we can remove the water pump, cam thrust bearing and the end plate itself. We're now in a position to remove the cam, but for this the cam followers must come out first. On early engines, access to the cam followers is via side covers. These are simply removed and the cam followers lifted out. On later engines, there are no side covers, so the engine must be turned upside down onto the cylinder block face to allow all the followers to drop away from the cam before cam removal can be accomplished. At this point, many items can be removed without any particular order being followed. Such items include the oil filter assembly, the distributor, its location flange and drive gear. While in the process of removal, check the gear teeth on the distributor drive gear. If they're worn, it will cause ignition timing scatter, which leads to a loss of power. Here the oil pressure relief spring and valve are being removed along with the oil pressure gauge union. Now it's time to turn our attention to the crank assembly. Removal of the connecting rod big end nuts and caps is next. These parts should be laid out neatly on the bench so that each component always goes back onto the same rod assembly. Although the crank is going to need a regrind, it always pays to take care when pushing the rod bolts past the crank journal. The bolt threads can easily put a nick into the surface of any of the non-hardened cranks. Once the rod has been pushed out, loosely reassemble it with the appropriate cap and nuts. Using a large Tommy or breaker bar, the main bearing bolts are released and the main bearing caps removed. It is essential that they return in the right order to their original positions. The crank can now be lifted out. As it happens, our beat-up old project car had a genuine Cooper S engine in it, the crank being the nitride-hardened EN40B item. The final stripping of the block assembly now entails removing bearing shells, sliding out the cam, and then releasing the oil pump. Now's the time to start the basic cleanup of all the parts that are serviceable or likely to be reused. Because the bodywork of our project car was a little on the rough side, it was evident that major surgery would be required to remove rust-damaged areas. To facilitate this, the car was stripped to the basic shell, starting with the removal of the front and rear subframes. The basic body shell was then taken to Auto Engineering, who are experienced at body restoration. As you can see, our Mini is in good company here. With the car suitably raised on body jacks, a hammer inspection of all the suspect rust points begins. Here, knowing where to look is essential. Rust damage as extensive as seen here severely weakens the vehicle's structure. If it is to be returned to pristine condition, each area of rust must be found. When it comes to Minis, there are always specific areas to examine, so even if you're only thinking of buying a second-hand Mini, then this will guide you. Sections like sills, floor panels, outside panels and the rear valance tend to suffer. In this case, the rust was quite extensive. While the project car's bodywork is being taken care of, work on the engine is proceeding. This narrow area between the bores has to be carefully checked. If the block has ever been overheated or seized, it can crack here. Take a good look at the cylinder walls and check for scratching or undue wear. There may also be damage to the bottom of the bores if the engine has ever suffered a rod breakage. The core or freeze plugs in the engine look to be in very good condition here, but would normally be replaced on an engine of this age. Also, over-tightening the main bolts or a rod failure can cause cracks under the main bearings, especially on the center main.